Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going over section 9.8, a system called Complete the Square. Now please note, I am still rather ill while I'm making this video. I will try to get healthier in the next few days. Hopefully I'll be back in person by Thursday. Okay, so completing the square is a method for solving a quadratic equation or a quadratic function that requires pretty little effort, actually. What we're going to be doing is a algorithm or a series of instructions that once we get down will lead us to the correct equation every time. Now, in our previous lesson we saw something like 16 is equal to x plus 2 squared. And we would use something called a square root to determine what x was. We take the square root of both sides, so we'd have plus or minus 4 is equal to x plus 2. And then we'd subtract 2 from both sides and get negative 2 plus or minus 4 is equal to x. Now this worked out really nicely because the original portion that we started with was already a perfect square binomial. If I was to FOIL that out, I'd have x plus 2 times x plus 2, which gives me x squared plus 4x plus 4. So the trick that we are going to use is we are going to transform a trinomial into a perfect square binomial. And the way we do that is through a method called completing the square. Now this method starts out with looking at our middle term, which is going to be called b. So let's say for a moment that we are given that y is equal to x squared minus 4x plus 3. Let's call this 0 over here. And we're told to solve for x. Now, at this moment, you might be able to say, oh, Mr. O'Neill, this one's really easy. You would say that this is x minus 3 times x minus 1, and by factoring, be done. And then you would get the numbers of 3 and 1 for your zeros. Well, that's great, but we're going to be using a method called complete the square, which will also create these two numbers at the end. So we're using this as what's called an example. Okay, so for this particular example, we start with the first portion of it, which is looking at our b value. And what we are going to do is we are going to create another number off to the side that forces it to become a perfect square trinomial. So my first move is that I'm going to subtract 3 from both sides, and I'm going to have negative 3 is equal to x squared minus 4x. Now note, if I had a number in front of the x squared, I would then try to get rid of it, but we luck out in that we don't have a number there, so we don't have to get rid of it. Now, the next thing is that I'm going to add 0. I know what you're thinking, but Mr. O'Neill, adding 0 doesn't do anything. Well, it's a special 0, a very special 0. This special 0, when we add 0, comes in the format of b over 2, except that we're going to add b over 2, and we are going to subtract b over 2. b over 2 minus b over 2, of course, is 0, so we're not really changing the value of it. We're just adding a 0 that forces it to become a perfect square trinomial. So I am going to add negative 4 over 2, and I'm going to subtract negative 4 over 2. And when I do that on my next line, I have negative 3 is equal to x squared minus 4x minus 2, and then plus 2. Is that the right one? Oh. I'm supposed to be squaring these guys. Oops, my apologies. It's b over 2 squared. It's been a while since I've done these. So this will be a negative 2 squared and a positive 2 squared, which gives me negative 3 is equal to x squared minus 4x minus 4 and then plus 4. Now, remember what I said about making it a perfect square trinomial? Is it possible to have a negative value for your c value if you have a perfect square trinomial? The answer to that question is no, it has to be a positive value for your c. So I'm going to add this 4 to both sides. When I do that, I now have 1 is equal to x squared minus 4x plus 4. And I think we know what this factors into. That factors into x minus 2 times x minus 2, which is really x minus 2 squared. Now we use the same technique that we used in our previous lesson. We take the square root of both sides. The square root of 1 is either positive or negative 1. And then we have that is equal to x minus 2. Adding 2 to both sides, I now have 2 plus or minus 1 is equal to x. 2 plus 1 is 3. 2 minus 1 is 1. So for my x values, I get the same ones that we could have done using our previous method. Now, at this point, you'd probably be saying, Mr. Neal, why are we learning this method? It's way harder than factoring. Well, sometimes stuff doesn't factor. And if we run into a situation where we run into a polynomial that doesn't factor, we need another method to figure it out. That's what completing the square does. Completing the square takes all those special cases that don't factor and makes it possible to figure out what the answers are. So let's take a look at another one. Let's see if they have a good one here. Okay, let's say that we have x squared plus, 16x is equal to 15. Now at this point, you'd be tempted to bring it over and try to find out the factors of 15 that have a difference of 16. Well, there aren't any, so we can't. So if we tried to do this the old-fashioned way, it wouldn't work out. However, we have a new technique. That new technique is called completing the square. And what we are going to do is we are going to find an irrational root to this particular problem, or irrational answer solutions, etc. Now I'm going to take that x squared plus 16x, and I'm going to put it in green, and that's still going to be equal to 15. Now I add and subtract my middle term over 2 squared. My middle term is 16, so 16 over 2 goes into each one of those places. We then do some arithmetic, and we have x squared plus 16x plus 16 divided by 2 is 8. 8 squared is 64. I want to keep the positive version on this side, which means that I'm going to add 64 to both sides. That gives me x squared plus 16x plus 64 is now equal to 79. At this point, we can factor this. these will always factor into the square root of this one and the square root of this one. So we're looking at x and then 8, and because positive is dominant, it's going to be x plus 8 squared. From here we can take the square root of both sides like we did in the previous lesson. Subtract 8 from both sides. And voila, we have the two answers for our quadratic. Now you'll note that I'm just stopping here. I'm not going on to the next portion, which would be to like figure out what the square root of 79 is in the decimal form. And that's because, to be honest, I like this form way better. This form makes me smile and be happy because it lets me have an exact answer. Whereas if I moved on and I took the square root of 79 and then I added it and subtracted it from -8, then I would end up with estimations, not exact answers. You can always take an exact answer and turn it into an estimation, but you can't always take an estimation and turn it into an exact answer. It's kind of like beef jerky. You can make beef jerky from beef, but you can't take beef jerky and turn it back into beef. It's kind of a one-way street. So let's look at another one that will probably be a little more difficult. Let's say that we are given x squared minus 2x minus 2. And we're told to solve for x. Now on this one, we'll note that there are no 2's, factors of 2, that have a difference of 2. So we have to use the complete the square method. To do this, first I isolate my x squared minus 2x from the rest of my equation. So I'm going to add 2 to both sides. And that gives me x squared minus 2x is equal to 2. Now, here's where I add 0. This is the most important step. And the way we add 0 is that we have b over 2 squared. We're both adding and subtracting b over 2 squared. So here my b value is -2. So on my next line, I would write x squared minus 2x and then plus b over 2 squared minus b over 2 squared. Sorry about that. You can probably tell why I'm not at school today. Not feeling so good. Alright, now this is still equal to 2, brought down from up here. From here we go -2 divided by 2 is -1, squared becomes +1. So I have x squared minus 2x, and then I have both +1 and -1 is equal to 2. Again, I want to keep the positive on the side with the x squared. So we'll have x squared minus 2x plus 1 is now equal to 3. This portion will always factor into a perfect square because it's designed to. And when we do that, we get x minus 1 times x minus 1 is equal to 3, which gives us x minus 1 squared is equal to 3. Take the square root of both sides. We have x minus 1 is equal to plus or minus the square root of 3. Add 1 to both sides, and we have x is equal to 1 plus or minus the square root of 3. And that's pretty much the whole method. The biggest and most difficult portion is the adding 0 portion. Once you get that down, the rest is pretty easy. By pretty easy, I mean like stuff that we've already done easy. Alright, so let's go ahead and do one more example and then call it a night. let's say that we are given 3x squared minus 10x, and then plus 3. Let's set that equal to 0. This one is going to create a lot of fun because these are going to be fractions. When I have this 3 out front, I need to get rid of it first. So the first thing that I'm going to do is isolate this portion and then divide both sides by 3. So isolating this portion, I get 3x squared minus 10x is equal to negative 3. I then divide both sides by 3. Then I get x squared minus 10/3 x is equal to negative 1. From here on, things are going to get a little fun, because my 0 is still in the format of b over 2 quantity squared. Except now, instead of my b being a nice whole number, my b is now 10/3 over 2. And that quantity is going to be squared. So how do I deal with this Franken fraction? Well, one step at a time. I'm going to turn this 10 over 3 divided by 2 into 10 over 3 times 1/2. Because it's the same thing. If you look at this, this is the same thing as 2 over 1. And what do you do when you divide by fraction? That's right, you flip and multiply. When I do these, of course you guys know all about reducing. I get 5 over 3. And that's going to be quantity squared, so it would be 25 over 9. Because 5 squared is 25, and 3 squared is 9. Okay. So on my next line, I would write down x squared minus 10/3 x, and then plus 25 over 3 minus 25 over 3 is equal to negative 1. Again, I want to keep the positive portion on that one side, so I add 25 over 3 to both sides. And that gives me x squared minus 10/3 x plus 25. Actually, that should be 25 over 9. My apologies. 25 over 9. 25 over 9. 25 over 9. 25 over 9. And that's going to be equal to, let's see, that would be 9 over 9, so 25 minus 9 would be 16. So that's equal to 16 over 9. Now the beautiful thing about this is that even though it's a fraction, I know it's a perfect square fraction, so I can just take the square root of it, and that will give me the portion that creates this as being a perfect square. And since it's 25 over 9, I would take the square root of 25, which is 5, and the square root of 9, which is 3. This sign still tells me who's dominant, so it's a negative that's dominant, and it will turn into x minus 5/3 quantity squared. And that's going to be equal to 16 over 9. Then take the square root of both sides, and I have x minus 5/3 is equal to plus or minus 4 over 3. Adding 5/3 to both sides, I have x is equal to 5 over 3 plus or minus 4 over 3. Doing some pretty fancy arithmetic, this turns into 5 over 3 plus 4 over 3, which is 9 over 3. And also 5 over 3 minus 4 over 3, which is 1 over 3. 9/3 reduces to 3. So I have zeros at the coordinates of x is equal to 3 and 1/3. So note how we do these. The first step is, of course, to isolate the portion that's an x squared and an x. The second thing is to get rid of whatever number is in front of the x squared by division. The third step is to add your special 0. The fourth step is to factor it into a perfect square binomial. Take the square root of both sides, and then you're done, pretty much. Completing the square seems complicated, but not really. Just do it one step at a time, just like cleaning your house. Step 1, turn on the light. Step 2, say, oh my god, my house is dirty. Step 3, start picking up stuff and putting it away. Alright, that is it for today's lesson. It is time for you to get to work with your homework. So this is the before you go work. And we are going to be looking at section 9.8. Hashtags math are awesome. Sorry, math is awesome. Illnesses are bad. And make sure that when you do get sick to go to a doctor before it becomes worse. Because I should have just gone to the doctor instead of waiting. Now I'm going to suffer more because of it, but oh well. Alright, let's go 1 through 17 odd. And then 21 through 39 odd. And of course, number 47, because you guys need more practice with word problems. In fact, I'm thinking that in the near future, one of our tests will no longer be a solve this equation kind of test. It'll be just nothing but word problems, because to be honest, word problems are what makes math useful. Without word problems, you have this area of ideas which is called math, and this other place called reality. And to go from math to reality, you use something called word problems. Because very, very rarely are you going to find a case where somebody goes up to you and says, hey, solve this problem for your job. It just doesn't happen. They're always going to be in the format of word problems, so you need to get them down. Alright, that's all for today. Good luck and have fun.